Hi everyone, I'm Petar from Curvy, and today I'm here to share with you the unfiltered version of the story, which is sometimes painful, but it is anyway always interesting and exciting about building a privacy protocol and how it actually looks like behind the scenes, what is happening, what is the thought process. It's been 2.5 years, almost 2.5 years since Vitalik published this blog post about stealth addresses. And stealth addresses are a very powerful concept, simple and powerful at the same time. Basically, you can register your ENS, so let's say, have your username, and when I know your username, I can generate, without any intervention from your side, I can generate a new deposit address for you and send assets to those addresses. And basically, no one externally can connect which addresses belong to you. Only your wallet will aggregate those funds, and only your wallet will be aware what are the balances that belong to you. So in 3327, which is our research part of the company, we played around with different cryptographic primitives even before that, with some similar concepts, and we gave ourselves a task: can we build the protocol, the stealth address protocol, which is aligned with Ethereum, compatible with Ethereum, without requiring any change on the protocol side of Ethereum, and can it be more efficient than what we already have on the market? So we started digging deeper, and we wrote few research papers. The first one had this goal that I mentioned, like it needs to be compatible with Ethereum and it needs to be fast. The second one was, okay, if we achieve that, let's see how we can support stealth addresses to be post-quantum resistant. Then we said, okay, it would be cool if we have like a multi-sig option, and if people can actually organize themselves and have different rules in order to manage their assets within their organizations. And then at some point we said, okay, we learned something through this post-quantum resistant protocol. Can we implement some of these logic into the existing stealth address protocol and make it even more efficient? And that was a long process and very, very exciting. But at one point we said to ourselves, okay, it is time to go through this, from this research phase to actually building the product phase. And then we started exploring how the product, the privacy protocol built around stealth addresses could look like. And when you start thinking from the other perspective, from the end user, it becomes more and more challenging, because you have many other challenges that you need to solve. And these are like just some of them that had to be solved and that we started to think about, because, as I mentioned earlier, stealth addresses are a great concept, but they're a great concept for receiving funds. Once when you have funds and you protected your privacy during that process, you start asking yourself, okay, how can I move those funds now? The first thing is, like, if you have your assets spread around hundreds of addresses, logically at some of those addresses you won't have native tokens, and you want to ask yourself, okay, I don't have now funds to pay for gas fee. I can either sponsor those addresses with the native token in order to pay the gas fee and to move funds, but that will expose my privacy, so it kills the purpose of the stealth addresses. So we had to figure out a way how we can actually solve this problem of the gasless transactions or gas sponsorship from our side in order to protect user privacy. Then you have funds spread across many addresses, and you need to send some bigger amount. Then you come to the problem, how can you actually batch those transactions, again, by protecting your privacy. Then we want to be present across multiple chains and to enable our users to use our product wherever they want, and it needs to be aligned with their everyday workflow. So how do you solve that? And then we came to another important part of our product, which is called zk layer, which is important part for the spending and for keeping your end-to-end privacy. So on the left side, you can see how funds are going into the system. On the right side, you can see how you're actually managing those funds and how you're actually spending those assets, because it is important to have both parts to protect you and your privacy in order to have like the fully private protocol. And then you can imagine that we come to the new challenges across that. First, if you want to build something which is friendly for onboarding new users and for bringing the new mass adoption to crypto, because I strongly believe that if we solve privacy in the right way, it will actually unlock many new use cases and bring the totally new groups of users that we don't have today present here. And in order to do that, you need to be friendly to onboard the new people who are not familiar with our industry at all. And then there is here, Lazar, my CTO, and we come frequently to the point that when we have some challenge and I say we need to address it in this way, he says it is literally not possible to do that. And then we fight, and then we go back to the whiteboard, and then we start discussing, and then we find some middle ground. I often say that I'm lucky enough to work with the smartest group of people that I had a chance to meet. They're definitely much smarter than me, which is not that hard, but they're literally some of the smartest guys that I had a chance to meet. And basically, some of these solutions are already presented in other products, but combining all of them and making like the whole product which will actually address these many challenges is not something which exists on the market. So you need to go back and forth, back and forth, back and forth, and find the middle ground. And through all these, struggles and discussions, how we can actually solve and is some problem actually solvable with the tech that we have today, we needed to find the North Star. We need to find some common ground that we will say, okay, this is actually our end goal. This is what the product will look like, and this is actually the problem that we are trying to solve for users. And we need to, as a team internally, and you are actually the first ones who are out of the team who will hear about this, we need to find, okay, what is that actually problem that we are solving, and what are some things that are pillars of that product and the pillars of that these pain points that our users are feeling that we cannot have compromise with. So what we are actually doing, we are building a compliant, private, and fast crypto payments protocol. And what it means that it has to have several pillars that we always have to have in our mind and that we have to balance with. So Curvy needs to be usable in the first place, to put usability, then to be private, compliant, open, of course secure, to be fast enough, to be cost efficient. And you might say, okay, if you have these many things in your product manifest, it means that you don't have focus, which might be true at this phase, but this is not a sprint. This is not connecting all these pieces that exist already, but you need to find, to solve one problem at a time, and then when you solve one problem, you will come to another problem. Then when you solve that another problem, you will create another problem, etc. And this chain of problems that you actually manage to solve throughout time will become your innovation stack, and that's what will be the end value for our users. So let's break that down piece by piece. What do I mean by saying usability? First, Curvy should be intent-based. It means, you remember that I said about onboarding new people. Intent-based means that you just define what your end goal is, and Curvy needs to handle everything else in between. You don't need, as the end user, to know what is happening under the hood and how it works. You just need to say, okay, my goal is to send to this user 1,000 USDC. Whatever you have at your wallet, Curvy will handle everything else in between. Also, if you want to receive funds, it needs to be seamless. It needs to be easy, and it needs to work with your everyday workflow, either through ENS integration or receiving funds from centralized exchanges or wherever you have funds already. It needs to work out of the box without with zero complexity and without requiring those other players from the market to support you. And it should be simple. It should just work aligned with your workflow. Privacy as the second important pillar. Privacy is never 0 or 1. There are like many shades in between, many grades in between. But what it is important is that with Curvy, it can never go to zero, but you need to put like the power in arms of your user to decide how they want to balance the complexity of like speed, cost, and privacy at the same time. So you don't need to force them to be always fully private because it might not be the use case that they need at that particular moment, but you need to give them the options. Giving them the options mean that at some point we might be like the privacy aggregator, which will actually support you with offering the right routes for your transaction and your intents to be achieved with keeping your privacy, but with different privacy scores, so to say. So it will never go to zero on our side, but it doesn't need to be 100% private all the time if you don't need. You need just to have the options to choose what are your preferences. Compliance part needs to be built in the protocol side itself. At the very essence level at the beginning, basically you have two, on our cryptography, you have two private keys, spending and viewing key. And if you share your private viewing key with someone else, like someone who is doing audit, you can actually prove what are your addresses and what are your actions without giving them the control to move funds. On the other side, anyone externally without knowing your private viewing key cannot connect what are your actions and which assets belong to you. So it's fairly easy at the very beginning to prove your actions to someone who wants to regulators, but we also have some other checks, and one important part of the zk layer is actually to do the AML and KYT checks and to reject the transactions that don't pass those checks. So we make sure that the relayer part stay compliant as well. Openness. Openness basically means that we are not building a wallet, we are actually building a protocol. And the protocol needs to be open, the protocol needs to be multi-chain, and the protocol needs to be something that anyone can build on top of it. So anyone can come and build on top of Curvy, different applications, different business models. Anyone can actually align their business goals and their business model with what Curvy is offering. So you need to keep that in mind. Security is fairly easy because there is like zero compromise with that, and it is straightforward, so to say. Bear in mind that these pillars are not prioritized. Basically, as I mentioned, you need to keep them in the balance, but with security, there is no balance. With the security, you're just not making any exceptions. Speed. As I mentioned, with the privacy part, there is also like cost and speed to keep in balance. So you need to give to the end user the control, how much they want to sacrifice which part of that. And basically, what makes Curvy special as well is that Curvy can be as fast as the underlying protocol, underlying blockchain is. So basically, as fast as the blockchain that you are transacting at is, you will get the same the same results with Curvy. And if you're building like a real payment protocol for the wide audience and the wide adoption, basically it needs to be fast as the TradFi is, and to enable you like to pay with your card to any merchant and to receive like the response in less than I don't know, half second in order to make that transaction happen. So for like real world use cases, we need to balance that as well. And the cost, of course. If you look at the architecture of the stealth addresses, the architecture of the stealth addresses is like that you will have your assets spread around hundreds of addresses. So it means that once when you want to move those funds, by the nature of it, you will have a multiplier because you will have n addresses that you want to send those funds from, so you will need to pay multiple transactions and multiple gas fees, etc. And when we started digging deeper into like the cost structure and how the operations of the relayer will look like, etc., we came to at one point to the conclusion that it would be like 60 times more expensive than sending a regular transaction. So the question mark is like, where is the right threshold? I don't have the answer what is the right threshold because it is a very it is a very individual answer to that. How much is someone willing to pay for having like the fully end-to-end private and compliant solution? But on the other side, we all agree and we all have a feeling that 60x is not a good range. So we need to balance, we need to optimize, and we need to find what is the right way how we can reduce the cost, increase the speed and the throughput, but keep end-to-end privacy for the user and have all of that in balance. So that's, again, another thing that we need to have in our mind. In a nutshell, if you look like, since we are talking with many people, and then someone will say, okay, there is this product which is solving this or using this, it is true, but what Curvy is definitely not. We are not a mixer, we are not a privacy pool, we are not yet another stealth address protocol, although this whole story and our initial product started with the stealth addresses, and although stealth addresses are a very important piece of this puzzle, it's not the only the only part, and we are not tied or married to any specific tech solution. What we are actually building, we are building a modular payment layer that should have like privacy and compliance embedded on the protocol level, and that is designed for real-world use cases. That means that it needs to be scalable and that it needs to be aligned with your everyday business models that we are already used to. We just launched to mainnet a week ago, less than a week ago actually, and we onboarded the first 100 users. Maybe some of you are among them actually if you participated at the hackathon here at ETH Belgrade, or if you flew with the airplane from Prague to Belgrade, you most probably then staked your funds through Curvy. So I'm beyond thankful also to the ETH Belgrade team, because like when I spoke with Petar said, okay, we need a solution for this staking use case, and we didn't even think about that particular use case of staking for hackathons. So basically anything that requires payments can be shifted, and translated to Curvy, that requires payments and privacy and compliance at the same time. And that's why I'm like really excited about, because like we can shape together how these products will look like. My goal for today was actually to share with you how this 2 years process looked like from our angle, compressed in this like 15 minutes talk. I hope like that a year from now, when we meet again here in Belgrade, I'll be able to share what actually worked and what didn't work in the meantime. And I hope that all these ideas that we presented during this talk will actually be live at that point, and we'll be able to share also like the both success and failures. That was it from my side for today. Now we can switch to questions. Thank you.
Yeah, first a silly question. Do you support hardware wallets, right?
Not yet, but yeah, it should be supported in the near future.
Okay, and do you use in any way the 7702, since you guys seem to be pretty active with EOAs, right? That's how Stealth Protocol works, and you have plenty of them. Is there any use case for you from this particular EAP? 7702, yes, the delegation.
Well, yeah, we are exploring that for the relayer part, the architecture of the relayer part. Basically, for the stealth addresses as such, or for entering, the system, it is not feasible. It can be, but it requires, different flows of funds, and then you will break some of these pillars that we discussed about, like openness. You wouldn't be able, for example, to send from centralized exchanges, etc. So it can be done, but it will have, some different things to consider regarding like the cost, the openness part, and that's exactly like some of these questions were also like our internal discussions. Then when we needed, to define these pillars and to see, okay, what are the things that we cannot break during our like architecture process, in order like to find like the perfect solution that will fit the use cases that we need. So yeah, we are considering that for the relayer part. For the stealth addresses part, it is still not feasible because we didn't figure out a way to build it without breaking the openness and cost part.
There is a discussion going on, I forgot the name of the EAP, that Ethereum might support so-called wormholes or something like, private ETH transfers where you can burn and mint it and nullifier is in place on the protocol level. So what's your take on this and, in general about supporting more of a privacy tools on like L1, not on the infrastructure level, but by the protocol itself?
Yeah, it's a good question because I think that basically, for similar pain points, you have different approaches how you can solve that. What was like from the very beginning for Curvy, if you remember, I said like it needs to work with Ethereum and it needs to be compatible that the protocol itself doesn't require any changes on the underlying protocol level. So maybe even the protocol is not the right term in this case, because when I say Curvy protocol, someone might think that it is like L2 or that it is something which is like going in parallel with Ethereum. It is not true. It needs to be like aligned with your flows. So when we have like obviously privacy is very important for the Ethereum roadmap itself, and we can expect some changes on Ethereum side to happen, which will support other use cases and make most probably our life easier with building these kind of products. But until it happens, like there are also other part and other missing pieces of the puzzle that we need to solve on our side in order like to have this wrapped up product that can actually be bridge between like Web2 business models and what we want like as the Web3 adoption. Any more questions? I assume that would be it. Thank you very much.